So welcome to the learning series. This is where we're going to look at the new exam. So we're
Is
going to
that
look
you
at
there, Roy,
the
in that
new
cartoon?
basic. Pardon me?
Is that you there, Roy, in a cartoon in the previous slide, pointing at the sine waves?
No, no, this is me here on the left.
The wider mustache. That's all.
So we're looking at sections 3.1 to 3.5. So this probably is where the most of the changes have occurred in the exam, is in this section and the other 3.6 onwards. So so anything that's in bold is a new question. And what they're actually allowing you to do is to take an aid into the exam. So you can download this from the ISD website. So what you get is you get two PDF files. One is more of a study aid, and the other one is an exam aid that you can bring into the exam. So they're all identical except the exam aid is unlabeled. So for example, the study aid, which you can't bring into the exam, and then the reference material or exam aid, which you can bring into the exam. So this is what the study aid would look like. So here they would give you the formulas, and over here they would give you what the formula actually means.
So a question, Roy,
Yes?
can you create your own, or you can only use the ones they have made?
You can only use the ones that they've made.
Okay.
Wow,
So,
that's an extra thing for the examiners to spot check.
yes.
That
So,
it's official. Like
yeah.
it doesn't. It's not a bogus replica of the printout.
No, you have to print it off, and like it says here that this material is not permitted for use during any
Yeah.
examination. Now, the other thing that they also provide, this is like a 5-page document. They also provide, for example, these diagrams of different receivers and different transmitters. And what they used to ask is, where is the IF amplifier located? Now they're asking more questions like, what does the IF amplifier do? Rather than asking where a part is. So this has changed quite a bit in the exam questions.
Which
And
is
then
good
yeah, and
because
here,
yeah, this way, because a lot of these people, they just memorize the diagrams and then
yeah,
they don't learn anything.
yeah, here's another diagram from the study aid. This is a typical HF setup. So this is what you can study from on the study aid. But when you take the reference material or the exam aid in, you get the same material, but you don't get the explanations. So you just get all the formulas listed. And then if you looked at this diagram here, it doesn't actually tell you what it is or what any of these parts are. Although if you pick up the symbols from electronics, you know that this is an amplifier, this is a mixer, this is a filter, this is a demodulator, this is an amplifier, that's a speaker. So you can recognize things by the symbol. And for example, this is what the HF setup would be. Again, same, but nothing is labeled. So we're going to look at operations technical, and we'll cover 1 to 5 and 6 to 10 today. And then we'll cover the rest next week. So here are some of the questions on HF station layout. To be most effective, where should a low pass filter be connected in an HF station without an external power amplifier? And this is a filter, a low pass filter, so it should be connected as close as possible to the transceiver output. In an HF station that includes an external RF power amplifier, where should the low pass filter be located? and that would be D, as close as possible to the external output of the amplifier. Why do modern HF transmitters have a built-in low-pass filter in the RF output? So what you want to do is prevent harmonics from getting out onto the air. That's why they have a low-pass filter. So the correct answer is C, to reduce harmonic emissions. When a component in an HF station is used to determine if the antenna system impedance is matched to the transmitter, so what you would use here is an SWR meter. What is the purpose of an antenna switch in an HF station? So the answer here is D, to select the desired antenna or dummy load. Here's a new question. In an HF station, which device might allow the use of an antenna on a band that it was not designed for? So here you would use an antenna tuner, and that would try to match the antenna to your transmitter. If an HF station, which component is designed to dissipate RF energy and prevent radiation? So that would be B, the dummy load. Another question, in an HF station, right after which component is the SWR meter inserted? So it could either be after the, it would be after the low pass filter. That's where you would put the SWR meter. Here's a new question. When using an HF transmitter with a solid-state final amplifier, which station component may need to be adjusted when changing frequency? So the only one that you can really adjust here of all of them is C, the antenna tuner. Now we're getting into transmitter, FM transmitter layout. So what does the microphone produce in an FM transmitter? So the microphone is an electrical signal driving the speech amplifier. Here's a new question. The microphone of an FM transmitter, the only one that makes sense here, is produces an electrical signal from air pressure changes. Your voice changes the air pressure, and that gets converted into electrical signal. So that's the purpose of a microphone. An FM transmitter modulator affects the frequency of the oscillator. How is the oscillator in an FM transmitter different from oscillators in AM/CW and SSB transmitters? So because you're using FM frequency modulation, the modulator alters its frequency. So you're switching the frequency. Here's a new question. In an FM transmitter, the frequency multiplier is B, produces the FM output carrier frequency. Here's another new question. In an FM transmitter, which stage produces a useful harmonic? So usually what you do is you have some sort of frequency multiplier that generates the harmonic that you want. So B, the frequency multiplier, is the answer. Here's another new question. In an FM transmitter, which stage draws the most electrical power? So that would be the power amplifier. So B is the correct answer here. Now we're getting into the super heterodyne receiver. So in a super heterodyne receiver, which stage is called the front end? So the front end is where the antenna is connected. So you may have the next stage would be an RF amplifier. Here's a new question. In a VHF super heterodyne receiver, which stage must be designed to produce very little noise? So that it doesn't matter actually if it's VHF or any kind of super heterodyne receiver. It's the RF amplifier that has to be designed for very little noise operation. Another new question. In a super heterodyne receiver, which stage allows the detection to function at a single frequency regardless of the received frequency? So that's the mixer. The mixer allows you to receive any frequency regardless of what frequency it is. Here's another new question. In a super heterodyne receiver, which stage has the received frequency? So here, the received frequency would be the local oscillator. Another new question. In the super heterodyne receiver, which stage rejects signals from adjacent channels? So that would be your IF filter, because the IF filter is tuned to a specific frequency and it rejects signals outside of what it's designed for. Another new question. In the super heterodyne receiver, which stage provides the final signal power to drive the detector? So the IF amplifier would be the one that drives the detector. The detector is the demodulator. Another new question. In an FM receiver, what is the purpose of the limiter? So the limiter removes amplitude variations from the received signal. Another question. In an FM receiver, what is the purpose of the discriminator? So the discriminator, it recovers the original modulation from the carrier. Here's a new question. In a receiver, what stage is controlled by the volume control? So the AF amplifier or audio frequency amplifier has the volume control. Another new question. In an FM receiver, which stage includes the squelch control? So the squelch control is also part of the AF amplifier. So the squelch would be part of the AF amplifier. So now we're getting into CW transmitter layout. So another new question. In a basic CW transmitter, the output from the oscillator is, in this case, it would be at the transmitted signal frequency. So A is the correct answer. In a basic CW transmitter, what stage of electricity directly powers each stage? So here, each stage is powered by direct current, which comes from the power supply. A new question. In a basic CW transmitter, why is the oscillator followed by a driver buffer stage? And the reason for that is D, to prevent load changes from shifting the oscillator frequency. So usually the oscillator provides a very low level signal, and then it gets amplified or buffered by the driver stage. In the basic three-stage CW transmitter, what does the key do? So the key does is it controls the amplitude of the carrier. So when you click the key down, it turns on the carrier and sends out the carrier. In a basic CW transmitter, what does the power amplifier stage do? So C is the correct answer. It increases the transmitter's output power. It's a power amplifier. In a basic CW transmitter, what does the key do? So again, it switches the carrier on or off. Okay, now we're getting into single sideband CW receivers. So a new question, in a CW, in a single sideband CW receiver, what is the purpose of the antenna? So the antenna converts electromagnetic waves into electrical currents. So B is the correct answer. Another new question, in a single sideband CW receiver, what is the purpose of the radio frequency RF amplifier? And so it's at the front end. So it's to increase the sensitivity of the receiver. So A is the correct answer. Another new question. In the single sideband CW receiver, what is the purpose of the mixer? So the mixer converts the received signal into the immediate frequency, the IF frequency. So A is the correct answer. Another new question, in a single sideband CW receiver, what is the purpose of the signal generated by the local oscillator? So the local oscillator is mixed with the incoming signal to produce the IF frequency or the intermediate frequency. So C is the correct answer. Another new question, in a single sideband CW receiver, what is the purpose of the IF filter? So again, it's a filter, so filters out something. So C is the correct one, provides most of the selectivity of the receiver. Another new question, in a single sideband CW receiver, what is the purpose of the IF amplifier? So the IF amplifier is to provide most of the receiver gain. Here's another question. In a single sideband receiver, what is the purpose of the product detector? So the product detector is the correct answer is to recover the transmitted modulation. So the product detector is the demodulator, and you want to separate out the modulated signal. So D is the correct answer. A new question. In a single sideband CW receiver, what is the purpose of the signal produced by the beat frequency oscillator, BFO? So the BFO is mixed with the IF to recover the transmitted modulation. Another new question, in a single sideband CW receiver, what is the purpose of the audio frequency AF amplifier? So after demodulation, it's amplified. So D is the correct answer. Increase the level of the recovered modulation signal. Another new question, in a single sideband CW receiver, which stage could include an audio bandpass filter? So again, audio relates to the audio filter, the AF audio frequency amplifier. So A is the correct answer. So that concludes this part. So let me just stop the recording and then we'll go on to the second part.